work with what we got. So the problem is 1 over the square root, the 7th root of 1 minus 4x squared. Nope, can't change that. Okay. They say find the extreme values of the function and where they occur. So we're going to look for critical points. And that's when f prime of x, the derivative, is equal to 0, or it's undefined. And then, so let's start off there. They didn't give us any boundary points, so we're not going to look at the endpoints necessarily, unless if they're both shooting off to infinity, then we might know it's a minimum or maximum. So choose the correct choice below, and if necessary, fill in the answer box to complete your choice. Okay, so we're going to take the derivative. I'm going to rewrite this as a exponent for x squared to the 1 over 7th power. And then we're going to go ahead and take the power root of this. Take the derivative. Y prime is equal to 1 over 7, 1 minus 4x squared, negative 6 over 7. Then multiply by the chain rule, which is going to be the derivative of 1 is 0, and we have the derivative of x squared is so negative 8x. That's our derivative of our inside. To rewrite this, we're going to write it as negative 8x on top over 7. Then write the 7th root of 1 minus 4x squared. You don't need to rewrite it, but just so you guys can see, when will this ever go to 0? This will go to 0 when x is equal to 0. And when is this undefined? When is 1 minus 4x squared equal to 0? If that's ever 0, we're going to minus the 1, divide the 4. X squared equals to positive 1 over 4. I take the square root, x equals to plus and minus 1 over 2. Because we took the square root of 4, it becomes a 2. So we have also, looking at critical points, 1 half as well as negative 1 half. Alright, so then we're going to go ahead to follow up with this. We're going to draw a number line here. And we have 0, 1 half, and negative 1 half. So when does this graph go to 0? Again, we said that happens at 0. And then we have an undefined. So how does the slopes look? Let's go ahead and look at the slopes. The slopes between negative 1 half and 0, if I plug that into this function here, one thing to take note is that because the bottom is squared, that's always going to be a positive. But then, since it's 1 minus, that could be negative. This could be negative, but to the 6th power would always force it back to be positive. So we know that the denominator will always be positive here, and the numerator is what we're really worried about. So if it's negative there, it's going to be positive on top. And if it's positive, it's going to be negative on top. And again, that 6th power on the bottom makes everything positive, so we don't have to worry about it. So it's going to follow this trend here. So at 0, we have a slope goes positive, 0, negative. So the slopes tell me it's a positive, 0, and negative. That's going to be a local max. But according to the graph, it looks like we're going to go up and down and down. So this looks like it's going to be an absolute maximum for us. So now that we know that it happens at 0, if I plug 0 into my original function, that tells us our original y. So 1 over the 7th root of 1 minus 0 is just 1. So let's actually go and check this out. This is actually going to be a true thing. Let's go Desmos. I'm going to graph the graph. 1 divided by, we'll do a parentheses, 1 minus 4x squared. I think that's what it was. Close, and we're going to take it to the exponent of 7. Oh, whoops. What? Did I make a mistake? Let me go double check. Oh, whoops, 7th root. Gosh. 1 divided by 7. I didn't change it. Where did I mess up? Oh, it's a negative. Darn it. I didn't pay attention there. So just to fix this, so I don't have to redo it. I made a mistake because when I rewrote this on top, I forgot to put the negative sign. And negative changes there. This becomes a negative, so negative 7 over 7 becomes negative 8. Negative 8, that doesn't change. And everything else, this becomes a positive. And our slope is now negative over here, negative, positive, and positive. Yep, and that's actually what we reflect in the graph. The original graph goes, if we look at the graph, it's decreasing down, and we end up with a u value and then going up. So this is a negative slope, negative slope, negative slope, 0, and then positive slope, and then this positive slope here. Okay, let's take a look at another problem. Hopefully I don't mess up on the next problem. Oh, I should refer back to one more thing I should say. This is, because it's a negative to positive, that's a minimum. Okay. In this case, it's the local min. When we looked at the picture, actually. But how could we know that if it was a local minimum? We know this is negative, and then it's negative again, but it's undefined. So the limit as we go here is going to negative infinity. Oh, that's right. I'm sorry. The way we'd have figured that out is because our zeros here, what are our vertical asymptotes for this graph? When is 1 minus 4x squared equal to 0? We said it was 1/2 and negative 1/2, right? So these are vertical asymptotes. So we know they were going to go to infinity. So we know it's going to shoot to infinity. Gosh. Okay. And this is going to be coming down from infinity. Let's look at a problem like this here. We have y is equal to 4x over x squared plus 4. Our goal is to look for our extreme values, so let's go ahead and take the derivative. We're going to use quotient rule, derivative of the top, leave the bottom alone. Minus derivative of the bottom, leave the top alone, all over the bottom squared. We're going to simplify the top, 4x squared plus 16 minus 8x squared, all over x squared plus 4 squared. When I simplify, we end up with negative 4x squared plus 16 all over x squared plus 4 squared. We're going to simplify this again. Negative 4x squared minus 4 all over x squared plus 4 squared. Now when will this equal to 0? So fractions, you always want to make the numerator go to 0. X squared minus 4, when does this equal to 0? Careful, I made the mistake previously when I was looking at this problem, where I forgot to say plus and minus 2. Okay, so x would be plus and minus 2. That's my, if we look at the denominator, x squared plus 4 will never become 0. Okay, a positive plus a positive will never become 0, because x squared will always be positive. So let's go to graph our number line, our sign. We have a plus 2 and a minus 2. And let's go ahead and plug in some values. At 0, if I plug in 0 here, the derivative would be, that would be negative, negative, and of course the bottom will be positive. So we're going to end up with a positive derivative right in the middle here. That's positive. Remember, our derivatives at negative 2 and positive 2 are both 0. We found that out here. Now let's plug in something bigger than 2. Plug in 3. If I plug in 3, this is going to be positive over here. This is still negative, and the bottom is positive, so we're going to be negative on the right. And then on our left, I pick something like negative 3. This is going to be positive, because when you square it, it's going to be bigger than the 4. So it's going to be positive, negative, and the bottom is still going to be positive. So to look at this, we have a minimum at -2 and a maximum at +2. Let's go and figure out what those values are. If I plug in -2 to my original function, 4 times -2 over -2 squared plus 4, that's -8 over 8 is -1. On the right side, if I plug in 2, 4 times 2 over 2 squared plus 4, and where 8 over 8 is again also equal to 1. Okay. Let's go take a look at the graph, what this graph looks like. We're not supposed to, but let's go ahead and peek at it. We have 4x divided by x squared plus 4. And let's take a look at the graph. You will notice that we do have a max and a min. Oops, this one's 2. Oh yeah, sorry, yeah, 2. Okay. Now a couple things you want to take a note from looking at this graph. From pre-calculus, we know that we can say the horizontal asymptote. Asymptote is going to be y is equal to 0 because the denominator is bigger, and when the denominator is bigger in a fraction, we do have a horizontal asymptote. That means the graph doesn't shoot off to positive infinity or negative infinity here. It's going to shoot off and then level out at 0. That kind of tells us that our values of -1 and +1, right? If we look at the graph, here's 2, here's -2. It's going to be negative 1 and +1 here. Our graph is eventually going to go back to 0 on these sides. Okay. And we know if we plug in 0, we end up crossing through here. So we're going to end up something like that. Okay, so let's go ahead and plug in the answer. We have an absolute maximum at, on the right side, when it's 2, it's going to be 1. Let's go check answer. Well done. We have a minimum at x is, oops, that's not the right one. We have absolute minimum at -2. Whoops. We said it was -1 at -2. Let's check that. Nice work. That's it. Next problem. We already did this problem also in class. Last one, we're looking for the critical points to determine the extreme values of this problem here. We're going to say 3x square root of 64 minus x squared. I don't know what the graph that looks like. If I had to graph this by hand, I would probably hate myself. So the goal is to not do that. The goal is to just look for critical points, and that will tell us the key factors of this problem. So we're going to take the root of the front, leave the back alone, plus the root of the back, which is going to be 1 over 2 square root of 64 minus x squared. Chain rule that to be -2x, and then times the front, 3x. Okay, that's our chain rule, right? Now, this is going to look a little funny. We have 3 square root of 6x minus 64, darn it, 64 minus x squared plus, I'm going to rewrite it as -6x squared all over 2 square root of 64 minus x squared. We're going to have to write this fraction together to figure out what our zeros would be. But lucky for us, if we write a common denominator, I'm going to multiply the right side by the square root of 64 minus x squared over the square root of 64 minus x squared, and throw a 2 in front of that. And these guys simplify out. So we're going to end up with 6 parentheses 64 minus x squared minus 6x squared all over 2 square root of 64 minus x squared. I'm going to simplify the top. This is going to be 6 times this big number is 360 plus 24 is 384 minus 6x squared minus 6x squared. So we're left with 384 minus 12x squared. Hopefully I didn't make a mistake there. And then 2 square root of 64 minus x squared. Okay. Now, when does this equal to 0? That means we're making the top go to 0. 384 minus 12 x squared equals to 0. We're going to get rid of the 384. Negative 12x squared equals to 384. Okay, so we're gonna make it go to 0. That's a negative. Then we divide both sides by 12. X squared equals 2. Let me use a calculator here. 384 divided by 12. It's probably gonna be like, yeah, it's gonna be 32, I think. I think. Um, 384 divided by 12. It's 32, yeah. Then we take the square root of that. So it's going to be x is equal to plus and minus the square root of 32. We can simplify this to x equals to plus and minus 4 left over 2. 4 square root of 2. Now, I'm kind of shy about this, but let's go ahead and check to make sure these are critical points on the graph. Let's go to graph it. 6x and the square root of 64 minus x squared. Okay, and 4 square root of 2 is, what's the decimal value for that? 4 square root of 2 to the square root is 5.65. 5.65, just so we know it. And 5.65, yep, that's my 5.65. As you can tell, this graph is ugly, but no matter. So let's go ahead and draw a sine table, a sine chart, and we have negative 4 square root of 2 on my left and positive 4 square root of 2 on my right. We know the derivatives are 0 there, and we're trying to figure out what's the sign in between. So we have our derivative here. Now a couple things are, we want to make sure that we are able to plug in numbers. Let's plug in 0 first in between. If I plug in 0 here, that's 0. If I plug in 0 here, what do you think? Is that going to be positive or negative? On top, that's going to be positive. On bottom, 64 minus 0 is regular 64, so that's going to be positive. You don't have to do the math all the way. You just have to go ahead and tell me if it's positive or negative. If this was bigger than 4 square root of 2, I noticed something. If it's bigger, well, let's see. If it's bigger than square root of it's bigger than 4 square root of 2, what happens here? 4 square root of 2 is really 32. Here's 32. If I plug in 32 here, 64 minus 32 is still a positive number, okay? So we're still positive on the bottom. But if I plug in anything bigger than 32 on top, we know that this on top here will flip and it'll become negative. On the left side, if I plug in something that's bigger, that's a negative, let's say negative 6. Negative 6 squared is 36. 36 times 12 is 432. And 432 would be more negative, so we're going to be negative over here on the left side of this graph. Now we also have one more thing to worry about. Remember, critical points are, sure, when it equals to 0, but also when it's undefined. And that's something we always have to check for. So it's undefined. 64 minus x squared is equal to 0 when x is equal to plus and minus 8. Now why is this important? It's because if any number is bigger than 8, we have more negatives, and then you can't take the square root anymore. So here's another point right here. We have to stick 2 more points here. We have an 8 and a negative 8, and anything bigger than 8 or less than 8 does not exist. The derivative does not exist. It also doesn't exist on the main graph. If you look at the main graph up here, the square root, if I plug in anything bigger than 8, the square root would be a negative, and then the graph wouldn't exist. So the graph actually stops. We look at a graph here, and the graph actually stops after 8. See that 8? Negative 8? It stops because the graph doesn't exist because it will be imaginary.